Hello everyone. Today we're going to go over mapping and online tools. This is just to simply demonstrate the mapping techniques as well as online tools that are available to you. When analyzing stream health, it's important to take a holistic view of the entire watershed. To do this, it's important to understand the boundaries of the watershed and locations of impacts to water quality that could be within it. So in this chapter, we're going to talk about the importance of watershed mapping, topographic maps, and online tools. Alright, so let's jump into the importance of watershed mapping. So understanding watersheds is essential in order to interpret the stream health and water quality. Everything that occurs within a watershed is going to affect the water resources that are there, and stream health depends on a healthy watershed. When thinking about the water quality of watersheds, it's good to also think about the different land uses that make up the watershed that's going to inform the water quality. Natural environments have a slower overland flow due to trees and plants that's going to help the water soak into the ground, filtering it before it enters the stream and also resulting in greater recharge of groundwater areas. Whereas urbanized environments, they tend to have rapid overland flow, and that results in a higher runoff of water into the stream at a faster rate and without that water filtering itself before it enters the stream or creating any groundwater recharge. So mapping your watershed has a lot of benefits that come with it. You can use it to identify different sources of pollution that could be in the watershed, also to help figure out where you want to monitor, and it's going to help you have a lot of educational value whenever you're talking to your friends and other decision makers in the community to help you make informed decisions about what's going on inside your watershed. You're going to want to select a manageable size. So if your watershed's too big, sometimes that can get sort of hard to deal with. So you might want to select sort of a sub-watershed within that one. And again, our goal is to help show those boundaries that are defined by topographic lines within the watershed, as well as the land use that's in the watershed, so that you can know where you want to sample, help you identify those sources of pollution, and again, make informed decisions in your community. So topographic maps represent a specific area called a quadrangle. It's just a four-sided region that's bounded by any particular latitude and longitude on the Earth's surface. And they are showing the shape and elevation of different features on the Earth's surface by what are called contour lines that illustrate different levels of slope on the map. And we'll show you all this in another slide, but each map is also going to include a scale bar that represents the distance on the map relative to the distance that you would see if you were there on the ground at the surface. And they'll also have different symbols that show boundaries for things like counties or different surface features, buildings, roads, and other symbols that represent communication features like that. Here's some symbology that you're going to want to familiarize yourself with when looking at a topographic map. And this isn't a complete version, but you can find more at this USGS website if you're interested and you need more explanation. Here's a section of a topographic map, and you can see pointed out here are some contour lines. So the contour lines, again, they represent elevation changes on the map. And the darker ones are going to have the specific elevation, generally in feet. And then the lighter intermediate ones are not going to have a number associated with them, but you can deduce it because they all go down or up in specific intervals. The contour lines should never cross each other, and the closer together they are, that represents steeper terrain. So over here In this area, you can see all these contour lines are closer together, and over here they're closer together, so this shows a steep hillside, maybe even a cliff, whereas these areas over here are showing elevation changes further and further apart, which represents not as steep terrain. Contour lines can be demonstrated using a hand and a fist. So if you take your hand and ball it up into a fist and then draw parallel elevation lines from the top of your knuckle all the way down, that's showing the 3D picture of what you're seeing on a contour map. So if you were to lay your hand out straight and still see those lines, that's what you're seeing on a contour map. There's also something called rules of V that represent valleys and ridges. So valleys, the top of the V or the tip of the V is going to be pointing upstream from the direction of flow. Whereas a ridge, if the top of the ridge is an enclosed, sort of irregular oval, it's going to be, the V is going to be pointing downhill from the ridge. Alright, so here we've got different features that are going to be shown on a topographic map. We've already talked about the contour lines. Then there's roads. There's water, so those are the ones represented in blue, the stream, different lakes. Also got towns, so Lower Village and Stowe are a couple different towns represented, and then the green areas that are kind of grayed out is more forested. Here's what it might look like if you wanted to translate a topographic map to what you would see in real life. If you were standing here, you would be located here on the picture on the right. And you can see that there would be a house there and this giant, where all the topographic lines are closer together, shows the steepness of this hill. You've got a ridge top here, another ridge top here, and then these ridge lines going up to Ian Ridge and then Baxter Gulch. So here's a depression where here is a hill where elevation is increasing. So using a topographic map, how do you go about outlining a watershed? You're going to start with where the most downstream section is that you're interested in, and that is represented here by this star. And then you're going to mark all of the water, streams, rivers that is going to be flowing into this downstream section. And then you're going to want to put an X or mark somehow all of the ridge tops that you see surrounding the water features. And then you'll just go through and you'll connect the X's following the topographic lines. And that is how you can outline a watershed. Here's some places that you can go to screenshot or download your own topographic maps so you can do this yourself. First one is the Missouri Stream Team Interactive Map. We have a base map gallery that includes topographic maps over the entire state, over the entire nation actually. You could also go to the USGS website. They have topographic maps available. Also, MU or Mizzou's Ag Assessment has a topo layer on their website as well. So if you Google any of those, you should be able to find more topographic map resources so that you can do this yourself. So aside from using physical hard copies of maps, let's talk about different online mapping tools that you can use to outline your watershed. So the first tool we're going to talk about to evaluate the watershed that you're interested in is the Ag Site Assessment with the University of Missouri. So if you go to agsite.missouri.edu, they'll have an Ag Site Assessment tab that you can click on. It'll pull up a map. Basically, you'll just click a point on the map. You can adjust the size of the site area that you're interested in, and then you'll just hit this Generate Report button right here. And that will basically pull up a report that's going to have a lot of information in it for you to sift through. So it pulls back information like just a summary of the site location. It'll pull up local demographics, the hydraulic summary. So this is what watershed or multiple watersheds your site could be located in. And you can click the links of the number. Every watershed has a number associated with it. If you click on the link to that number, it will pull up a PDF of a map of the entire watershed that the site is located in. So that's a very convenient way to figure out the watershed that you're in and a map associated with it. They also talk about environmental concerns, different soils that are there, and a climate summary for the area as well. So this is a really nice tool. Would definitely encourage you to take a look at it if you're interested. How's My Waterway is another resource online that you can use to map out your watershed. It also has a lot of really good information that you can find about the water quality in your area. Once you search your water body or your location, it will pull up a dashed outline of the watershed area, and it's an interactive map, so you can click on the water bodies or different symbologies within the map, and it will give you information about maybe permitted discharge features or impaired waters, so you can just gain a little bit more knowledge about the watershed features. So now we're going to talk about some online tools that we have for you, like our Stream Team Interactive Map, USGS Water Data, and the Stream Team website that's going to just help you understand more about the program as well as get the resources that you need throughout your monitoring journey. If you go to our Stream Team website, mostreamteam.org, you can access water quality resources and tips to help you in monitoring. You can order new equipment. You can submit your activity reports as well as your online data. If you're looking to get involved with other stream teams or other things going on with the stream team program, you can go to the calendar of events and see what's going on in your area. You can also submit your own event with the calendar of events, and you can also access our interactive map. Let's go over briefly how to access and use the interactive map. If you're on the mostreamteam.org homepage and you hover over the About Us tab, the interactive map link is going to be at the very bottom. Whenever you click on that, you will see a page that looks like this. Sometimes it may take a minute for all of these sites to load, but as you can see here, we've got quite a few icons that pop up. So the first thing I want to do is describe to you the difference between these two icons. So if you go down here and hit the Map Layers button, it will show you a legend of what the icons mean that you have currently displayed. So right now we have the Stream Team Activities map layer, which are represented by the Missouri Stream Team icon, and right now they're grouped into how many of them are close to each other. So you could see there's like little groups with a number over it. So like there's 14 around here, 9 around here. So stream team activities are just where people have done any stream team activity, and that includes volunteer water quality monitoring activities. And I'm going to turn this layer off by selecting the hide the layer option, which is the little eye over here to the right. So I'm just now displaying the VWQM monitoring sites, and these are going to display both active and inactive sites. So you can see the legend here for that. The active sites are mostly black and the inactive sites are black in the middle, and then have a white outline around them. Inactive sites are sites that have not been either created or monitored in 3 years. So after 3 years of inactivity, we consider that to be an inactive site. So there are lots of other layers that you can access here that might interest you. The layer is gray if it's not able to be seen and you need to zoom in a bit further. So if I zoom in a little bit further, you can see here, okay, now I can access the stream classifications and use designations layer. And some layers will automatically turn on once you zoom in close enough. For example, if I zoom in a little bit closer, the streams layer is automatically going to show on the map, as well as the impaired streams, and the same for lakes. So feel free to play around with what different layers on here you might be interested in. Some of them will show the National Pollutant Discharge Elimination System, wastewater outfalls, and stormwater outfalls. So basically where there are wastewater treatment facilities or stormwater outfalls. We also have the HUC designations. So if you're interested in where the small watersheds or large watersheds. And then we also have things like live stream gauges as well. So lots of different things to play around with these layers. So I'm going to go ahead and just zoom out a little bit again. And now I want to show you how you can search for specific sites. So there's a filter icon down here, and you can go in and filter for any Stream Team activity or VWQM site by selecting this drop down arrow and then using, if you know what the site ID is, or if you're interested in specific streams. So let's say I want to see where all the sites are on Flat Branch, and then I hit apply. It's going to take me to where there are sites that have Flat Branch in the name. So in Columbia, Missouri, there's a stream called Flat Branch, and these are all of the sites on here, and I can see that all of these sites are not currently active. So you can do that similarly for, like I said, the site ID or what the stream name is. And then let's say I want to go back, I'm just going to hit this button to reset filters. So it'll take me back here. Another useful thing that you can access is the measuring tool over here on the top left. So this will show you where you can measure, let's see, like maybe I want to know on Cedar Creek here, how far is this site from Dry Fork along the creek. So I'll just start clicking along the stream here, and then whenever I want to be done, I'll double click, and well, sometimes it works. It can be a little finicky. There we go. And it will tell you how far you were from Dry Fork, and you can also change the metric or the unit that it's using. So you can change it to miles, yards, feet, and so forth. And then you can just hit exit whenever you're done. There's also different base map layers here. So we have the Missouri Stream Team topographic map as the base layer that it's defaulted to, but there's all these other different layers. So maybe if you're wanting more imagery or satellite imagery, you can change it. You can go to more navigation. There's older US topographic, or maybe more high resolution topographic. So there's lots of different base map layers to choose from as well. You can also play around with selecting different things and viewing the attribute table for the Stream Team activities or the VWQM monitoring sites. So yeah, lots of different things to play around with, but the interactive map can be very useful if you're just wanting to see where folks have monitored, as well as just gain information about more about Missouri streams.
Once you've completed a field training and are certified as a Level 1 monitor, your next step is going to be selecting a site. This process was detailed in Chapter 2 Site Selection presentation, but if you need more details about how to do that, you can refer back to that chapter. Data cannot be submitted online until a site is created or adopted under your user account in the database. To establish your first monitoring site or any subsequent sites, you can use the database to submit them to us, or you can email a map of your site to streamteam@dnr.mo.gov. This map should include your name, the name of the stream that you're monitoring, the county of your stream, and a verbal site description using permanent landmarks. If you're adopting an existing site from the Stream Team Interactive Map, you can also provide the site ID from the map information. Please do not submit a map or any data to us until you've completed your field training.
USGS is a recommended source that you can use before you go off and venture into your stream. This is going to help reduce unexpected surprises that you might see, as well as ensure that you have a safe discharge in your stream before you go out and monitor. USGS offers water data online to you. Not all streams have a USGS gauging station on them, and not all of them measure all parameters, but it might be good if you've had a recent rain event or a recent snow event and you want to see if the floodwaters have recently receded or if they've gone up before you go out and monitor. So from this home page for Missouri water data, you can click on a gauge on the map and view the available data there, or you can hover over the points on the map and it'll display the stream name and the location of the gauge. By clicking on the point on the map, it'll take you to a gauge that displays graphs of all the data available at that particular gauge. Common data to be displayed is gauge height, the discharge, and the precipitation. You can also change the dates and view a table format instead of a graph if you want. Just scroll down on the page to view the available data. This is an important tool to monitor river levels for your safety. As a reminder, the discharge data available on this site can be used to report on the discharge data sheet only if the gauge is located on the same stream within a half mile of where you're taking discharge, with no inputs or outputs, meaning no tributaries coming in or leaving the stream. So if you report using this data, you have to report the gauge station number with your flow data. So whenever you record your discharge data, you're either using our VWQM protocols or using a USGS gauging station that's within a half mile of your monitoring site, and there are no inputs and outputs between the gauging station and where you're monitoring.
When you go out and monitor or participate in Stream Team activities, we also ask that you submit an activity report. You can do this after you create an account with our database, as well as either create a stream team or become a part of a stream team. So once you do that, then you can submit activity reports to us. This helps illustrate our hours and helps the funding for the program continue. You can also request incentive items and enter prize drawings by submitting activity reports.
All right, let's wrap it up by going over some review questions. How are watershed boundaries defined? They're defined by the highest elevation points that are surrounding a specific drainage area. What do contour lines indicate? They indicate relief or elevation changes on the Earth's surface. Where can you find the interactive map? You can find it from the Stream Team website. When can you use a USGS gauging station for stream discharge data for your monitoring site? You can use it if it's located within a half a mile of your site and there are no inputs or outputs coming into your site. Alright, thank you guys for watching. You can contact us by any of these email addresses or places to go to on the web. mostreamteam.org is our website. You can email streamteam@dnr.mo.gov or streamteam@mdc.mo.gov. You can also find us on YouTube and Facebook, and that is our program phone number.